Mic test. Hi, everyone. Good to meet you all. My name is Jonathan, and I'll be sharing about how we, as Canva, scaled our data platforms to exponential growth. Firstly, a message shout out to the sponsors for today. Thank you all for putting on such a great conference. So a couple of questions before we dive into how we scaled our data platforms. I'm going to ask you to raise your hands if you have had customers complain to you about long lead times to ship products or features. Anyone here had that problem? Yeah? How about, do you feel like you have a never-ending list of backlog requests, people asking you for new features all the time? Anyone? Yeah. Are your apps taking longer to run and more costly and more expensive to actually finish? Yeah. And last but not least, are you experiencing burnout? Are you feeling dying in your job? Yeah, some people. Yeah. So this is not new. This is all pains that everyone here as engineers have experienced at some point in our careers. And I would like to describe that pain as molting pains of scale. So we've essentially reached a point where we design our systems to reach a certain capacity, but we're now kind of exceeding the limits of that capacity, and that's the kind of pains we're feeling. And an analogy I like to use here to describe this sort of pain is the humble Western Australian rock lobsters. So we have lots of rock lobsters here. Everyone likes to eat, hopefully. It's lobster season right now, actually, so go and get some. But the idea here is that like lobsters will grow, and eventually it comes to a point where they can't, the shell is the limitation of what they have, and they have to mold that existing shell in order to continue to grow and develop. So that's kind of what we need to do as our platforms scale. We need to think about how we can break out of the existing confines and think about what's the next phase of the platform. A little bit about myself. I'm a senior data platform engineer at Canva. I started a bootcamp called Data Engineer Camp as well, together with my good friend here, Douglas. And we've been running it for over 2 years now and trained over 150 people who now work at companies like Atlassian and Apple and so on in data engineering roles. And I've been building data platforms for the last 8 or so years for various companies listed above. A bit about the platform at Canva. So we process something like 26 billion events each day. That's events coming from clicks on a website, events from our backend systems or databases, events coming from third-party systems like Salesforce or Facebook ads and marketing and so on. We generate something like 90 million queries every month to process our data, and we store something like 25 petabytes of data today, and that number is growing very, very quickly. In addition to that, we're actually trying to delete data, and yet it's not doing anything. We're just accumulating data very quickly. We have 460 code contributors to our platform, meaning that we have data scientists, machine learning engineers, data engineers, lots of different people trying to build use cases on top of the platform. And we house something like 10,000 different data assets on the platform today. So lots going on in the platform, and because of the velocity and the scale that we're operating at, we have lots of problems with scale. I want to share with you 4 different lessons I've learned on scale and how we got our platform to where it is today. So the first lesson I've learned is to align our platform to business value. As an engineer, it's very tempting to build something like this golden toilet right here. When we look at big companies and the big techs of the world, like what Meta is doing, what Netflix is doing, it's very tempting to say, hey, let's take our lessons learned or take their lessons learned and apply it to ourselves. That doesn't always work. That's kind of like, sometimes it's cool, it's fun, it looks great to build something that seems complex, but what actual problem is it solving? What business value is it actually giving people? It's like building this golden toilet here. It looks good, but it's just a shitter at the end of the day, right? So what I like to posit or propose for us to think about when we think about what we want to build next, and this is what we do here at Canva when we design our platform, is to think about the value driver tree. So every decision, every prioritization, every decision we make about what we're going to be building next H1 2025 or H2 or 2025 is based on this model right here. We think about things in terms of value drivers. So I'm going to get my directions wrong. On the right side is your platform capabilities. So these are features that are existing within your platform. These are services you provide. And then on the far left side is business value, right? Bottom line, profits, things like revenue, profits, costs. How does it actually impact the business? And the trick that we're trying to get to is trying to figure out this kind of middle bit here that connects us from what we provide as a platform service to what business value provides on the far right. So the exercise that we like to do every quarter, every 6 months is to think about, okay, we're going to prioritize new features. Let's talk about how these features actually contribute to the value drivers on the far left. So if we say, okay, we're going to spend the next 3 months or 6 months building a certain feature to enhance our user interface tooling or whatever it is, okay, why do we do that? Well, we do that because it's going to help to shorten the time to insights. Okay, how does that help Canva? Okay, because shorter time to insights means that people can use our developer tooling to get better insights from their product at a much quicker rate. And so we can then increase the number of customers at Canva and therefore contribute to Canva's revenue. So that's the way we should be thinking about prioritization, is using this value driver tree. So that was the first big lesson, and since we adopted this framework, it's been very, very easy and very clear on how to decide and prioritize things. And we used to have debates all the time and theoretical, opinions about what things should be like, but this really puts things into perspective, and we don't waste so much time having opinionated discussions anymore. The second one is to choose the right topology of your architecture. An analogy or a concept I'd like to help us understand here is looking at how highways have evolved over the years. So everyone here drives, everyone here gets to places through vehicles, and so you understand how highway systems work quite well. If we look at the top diagram there, that's an image of a town in Arizona, and it has around 500,000 inhabitants. And because of its low density in population, it only needs 2 highways that are represented there in green. And the 2 highways basically takes people into the city center so that they can go to CBD, get to work and stuff like that. Interestingly, the bottom one is of a different town that has double the population of the first one. And what we see, two observations here. The first is that there are more highways to get people to the city center, but the more interesting observation is that now there's a red line appearing around the city center. And this phenomenon happens not just for this particular town, this happens for all towns in the world. Every big city will kind of have this sort of architecture evolve and kind of naturally happen by itself. Now, why is that? So the green lines, represents getting into the city, but as you can imagine everyone trying to get the city, if I want to go from suburb A to suburb B, I have to go through the city and then from the city out. It's going to create a lot of congestion at that city center. It's going to create a bottleneck in the city center, right? So everyone in Perth, you understand, going on a highway, right, going up north or down south, or on Kwinana Freeway, that's the worst experience, especially around 4 or 5 p.m. So that's the kind of experience that is being felt there. And so these ring roads or these red line roads start naturally occurring in bigger cities, right? And that's a philosophy I think we should think about when we design platforms as well. How do we create platforms that don't force a particular bottleneck on an existing path for a developer to want to do something with the platform, but how do we enable people to get to different places they need to go by themselves much more quickly? So yeah, how do we create these ring roads in our platforms? So everyone here knows microservices and the philosophy of that. I want to kind of explain and break it down for us here. So there are 2 different paths we can take. We can go with a fully centralized application development or a decentralized application development approach. Centralization just means building a monolithic application where all the pieces of the application are shipped together as one module or one product. Okay, build, test, ship, all as one thing. And we started out that way on the far left when we built our data platform at Canva. Okay, so we started in a monolith. And over time, we became the bottlenecks. The data engineering function became the bottleneck. And so we realized that, hey, we got actually to decouple some of these different services, these different domains of data models and things that we built, and give them to, break it off so that we can now ship and deploy and test these different pieces of code independently from each other, creating this sort of way to self-serve, this way to sort of drive that ring road philosophy. So we did that for the code aspects for the application side, but we also needed to do that on the people side. So according to Conway's law, he explains a concept that states that when we design systems, the way systems get designed is a mirror or a reflection of how we organize ourselves as people. So even though we decided to split our applications as such, we also needed to split our teams and how we allocate people to those different services to own those applications. So we initially started off on the left side as well, where we had teams for very specific functions of the data engineering process, like data ingestion, which is getting data into the warehouse, transforming the data once it's there, and then analyzing data using like BI tools. So we had very discrete functions like that. But today, we're moving these roles, and we're taking engineers with the skills to do each of these roles and embedding them within the product teams, within the domain teams. So today, if you work for a team at Canva, you might have a person who is skilled in software engineering, who can ingest data into their part of the warehouse, a person who knows how to run transformations using SQL or analytics engineering, and a person who knows how to analyze data, so a data scientist on your team as well. And that team is going to be, that individual is going to be working together with product managers and other software engineers in that team. So sounds great, right? Let's all go to microservices, right? Let's all do microservices tomorrow. No, let's not do that. Let's actually think about whether we need to do that or not. Going into microservices architecture will increase the overheads of management, of communication, of all that stuff. A lot of friction is going to introduce when we start to move towards a microservices architecture. Sometimes, and most of the time actually, it makes more sense to stick with your monolithic application until you reach a point where it becomes too expensive to keep running that monolithic application to scale because of complexity, the number of use cases that we're trying to support. Then we shift towards a microservices architecture. Oops, I think the slides are gone. Oh, it's back. So what I want to kind of help us to see in this diagram here is that we can start off with monolithic applications in the beginning, and then if we keep continuing with a monolithic application, at some point, when the application gets very, very, very complex, we start to see that the kind of impact that the application brings to the organization starts to actually decrease. So if we don't change anything, our impact starts to reduce. And at that point, that's when we should now really think about breaking the application up into microservices. Okay, so don't just go data mesh just because it's the cool thing to do. And the way in which you actually roll out data mesh or microservices is incremental, right? We did it incrementally at Canva as well. Initially, we had like a team of like 10 engineers who were responsible for the data platform and did all data engineering work for Canva when we were kind of early days, about 4 or 5 years ago. Eventually, we realized that we were being bottlenecks, especially on the dashboarding side of things. And so we said, we opened that capability up to its users. And now domain teams can hire their own data analysts and data scientists to build dashboards themselves. But then now the domain teams are saying, well, you're being the bottleneck still of the data processing stuff. So it's taking too long to transform data. So we want access to the data warehouse. So we did that. We gave them access to data warehouse. And then eventually they said, but it takes too long for you guys to actually bring data into the warehouse. Can you let us self-serve that process of bringing data into warehouse? And eventually we did that as well. So this change was something that happened over a period of 2 years. And eventually we got there, and that's kind of the architecture we have today. All right, the next point here is to build composable components. So this is an important lesson for me because let me ask you a question here. So there are different ways we can build developer tooling in a platform. We can expose what I call modular blocks of tooling in the platform. So, and then, like for example, in construction, you can allow people to build homes by using this apartment block. You can just stack apartment blocks together to build apartment housing. So that's one approach to software development or construction, right? Using modular blocks. Another analogy here is to use building materials. So you can go out and buy bricks, go out and buy concrete, and then kind of stitch things together, nail pieces together, and then paint things together, and then you build a house. So show of hands here, how many of you prefer to build houses with the modular block approach? Just a few, 4, 6 hands? All right. How many of you prefer to build houses with the building materials approach? More hands? Okay. So which is the better option here? Anyone? Depends? Yeah, that's right, it depends. What do you think as a platform should we give to users to have at their fingertips? Yeah? Both? Anyone? Yeah, so when we design platforms or when we create APIs for customers, we need to give people the ability to do both. So reason being that people might want to be building homes with the lowest level primitives, or on the other hand, some people might want to build homes using the kind of predefined blocks so that they can get building much more quickly. So that's what we did as well at Canva, where we built our own infrastructure as code tool in-house. I know most people probably use Terraform here, but we have something called Tundra that we use for database infrastructure as code that's built on top of a DSL called Starlark, which is built on top of Python. But essentially, on the right-hand side, on the left-hand side, I should say, we have a composable block that allows you to spin up an entire database together with schemas, together with roles and access control management, just by using 6 or 7 lines of configuration code, and it deploys all that for you. But if you ever need to do something custom, well, you've got your database primitives as well on the right-hand side, where you can deploy just a database alone. You can be very explicit on the different configurations, on the number of nodes in a database, and things like that. You can control every single primitive you want in a database. And coincidentally, when we developed this database primitives, that's what we actually used when we built our own composable blocks to expose it to users. So we allow users to actually use both. When a user wants to deploy a workspace for themselves or a namespace for themselves, they will use the composable block first, and any additional customizations they need to do, they can use this composable primitives to do that. So that's lesson number 3, is to design tools, expose APIs to users that allows them to have control on both. The last point here is how to drive adoption. So we've built a awesome data platform, but we want to ensure that our data platform users and contributors are using the platform according to our platform best practices. How do we do that? As we all know, there's the carrot and the stick approach. As I like to call it, I would like to refer to them as incentives and penalties. So I grew up in Singapore, I was born there, and in Singapore, we have a lot of government incentives to try to persuade people to behave a certain way in Singapore. It's very interesting. It's like a social experiment kind of country, if you will. In Singapore, there's this policy called the healthier choice option, where if you pick healthier choice food products, they actually sell it to you. The government subsidizes the cost of those products. And so you get to buy grains and healthier options for cheaper. So get like 5% discount, as it says there. On the flip side, Singapore as well has a lot of fines. All right? Anyone rode the public transport system before? Yeah, you would have seen these signs plastered all over the train walls. So we fine people for basically everything: chewing gum, smoking, eating or drinking, even durians on the trains. So that's to dissuade people from acting a certain way. So in the same way, if we want to kind of push people to behave a certain way and use the platform to our best practices, these are 2 different levers we can use to control that. An example here is data documentation. So, I mean, every software engineer hates writing documentation. Even if you write APIs, no one wants to document your API. It's just a hassle to do so, although it's a bit easier now with things like AI and stuff. But we face a problem when people are producing these data assets, that how do we get people documented, right? We have 10,000 data assets in production. Nobody wants to write docs. We tried all sorts of things to try and get people to do it and try to punish people who don't write docs and try to do things like that, but none of that was working. And what eventually did work for us is to use an incentives-based approach. What we did was very simple change here that we didn't really click initially. All it took was just a single line change where we added a little line in our career development framework. And this framework is how we determine performance reviews, promotion cycles at Canva. We added one little line there that says, well, if you document things, that's going to help you in your promotions. And just like that, everybody at Canva suddenly started wanting to write docs. So the principle here is, use incentives to try to navigate people to using your platform in a certain way. And something we're trying to do next H1, H2 next year is cost reduction. We spend a lot on our compute costs in our warehouse, and people are kind of writing costs and creating assets on the platform and incurring huge costs on the platform. So something we're trying to do next cycle as well is maybe add another line there that says if you help to reduce money, cost reduction in Snowflake and things like that. So that's something we'll try. Okay, so to summarize, these are the 4 lessons you can use to scale your platform. But the main takeaway here is I want us to kind of all appreciate and be like the Western Australia rock lobster. So if you experience the pains of scale that I talked about earlier, I want us to kind of think about, not just accepting the pain, not just accepting the status quo, but thinking about how we can actually break out of that and to use the lessons I've taught to help us to grow. All right, that's it for me. Do we have time for questions? No? Oh, good. All right. Cheers. Thanks, everyone.